Welcome back. So the first pattern we'll take a look at, it's not really called frequency counters. I don't think it's actually called anything officially, but that's the name I'm using because the idea behind it is that we use an object, usually in JavaScript, to basically collect a bunch of values and their frequencies. So this is useful in algorithms and challenges when you have multiple pieces of data, multiple inputs, and you need to compare them to see if they consist of similar values, if they are anagrams of one another, if a value is contained inside of another value. Anytime you're comparing pieces of data, two inputs or more than two, and frequencies of certain things occurring. And I know that sounds really wishy-washy and not that useful, but I'll show you a couple examples. So what makes this a good approach and a nice pattern is that it's usually O of n time compared to the easier solution, which often involves nested loops, which is going to give us O of n squared quadratic time. So let me show you an example problem because this probably doesn't make much sense yet. Okay, so here's a challenge. Write a function called same, which accepts two arrays. And the function should return true if every value in the array has its corresponding value squared in the second array. So in the first array, there's a bunch of values, and we want to know if the second array has the exact same values but squared. But the order doesn't matter. So it doesn't have to be identical, just squared. It could be mixed up. But the frequency of values must be the same. So here's an example. 1, 2, and 3, and 4, 1, and 9 should return true. So 1 squared, that's in here. 2 squared is in here, 4. And 3 squared is in here, 9. But the order is mixed up, and that's okay. However, something like this, let's look at the second one. 1, 2, 3, comma, 1, 9 is false because it doesn't include 2 squared, which is 4. 1, 2, 1 and 4, 4, 1 is also false because the frequency needs to be the same. So just because 1 squared is in this array, and 2 squared is in this array, doesn't mean that the frequency is the same. So we need to have 1 in here 2 times because we have 1 and another 1. We need to have 4 in here 1 time because that's what we have over here, right? 2 is in here once. So the frequency matters. It's not just checking if there is a 1, if there is a 4, if there is a 9. It's making sure there's the correct number. So if you want to try this, go ahead and pause it. You don't have to try with this frequency counter pattern, which we haven't really introduced. But if you want to, you could try that or come up with a nested loop solution. But here is what I don't like calling solutions naive because they're often not that easy to come up with, even when they're labeled as naive. Naive more so just means not the best possible solution in this case. So here's a naive solution where we use nested loops. Technically, we're only writing one loop, but then we're using index of, which is itself looping. So I'm going to hop over and demonstrate how this works first, just to make sure we're clear on it. So the idea is we have two arrays. Let's say I call it with 1, 2, 3, and then my next array will look like, let's go with 9, 4, let's do 9, 1, 4, like this. Okay. And let's actually add another 2 in there and another 4. So this should return true because we have 1 squared, we have 2 squared, we have 3 squared, and we have another 2 squared, 4. Okay, so the approach here, the very first thing we can do to check, a nice little edge case, or it's not even an edge case, just we can tell immediately if the two arrays have different lengths, then we're done. There's no way for it to be true if there's an extra value in here that isn't over here, or vice versa. So we return false. That part's easy. That's a nice short circuit. But here, what we're going to do, I'm not sure where I added that S, return true. We're going to loop over this first array, or we could loop over the second one instead. And we're going to call index of, where we pass in the square of each value. So we loop over this array, we start at 1. And 1 is a silly example because 1 squared is 1. But we're going to ask, what is the index of 1 squared in array 2? So in our case, if we take 1, what's the index of 1 squared in this array? It's this index right here, which is index of 1. It's very confusing, a lot of 1s. And then what we do, we check if the correct index is -1, meaning it's not in there, we return false and we're done. Because if we had something in here like 5, and we're trying to see what index in array 2 contains 25, 5 squared. Well, nothing does. It returns -1. That means that we have a mismatch and we're done. But in the case of 1, if it is a match, and it is, it's right here, then we're going to call array2.splice that correct index, comma 1. And that effectively, what that does is it removes 1 from this array. So then we move on to 2. And then we're going to look at 2 squared. What's the index of 2 squared in this array? Well, there's 2 of them. It just gives us the first one. So it's going to return this index. So this is not true right here. We don't return false. We keep going. We live another day, another loop iteration, and we remove it from the array using splice. And then we look at 3 squared, and it's in there, so we remove it. Then we get to the end of the array, and we look at 2. What is the index of 2 squared? Well, that's 4. That's it. We remove it. We hit the end of the array, and we never returned false, so we return true. So you don't have to do this solution with index of. You could manually, iterate over the entire array yourself, which is basically what index of does. So we could have one loop and then a second for loop that loops over, let me Command Z a couple times, that loops over this array and looks for 1 squared. Is this 1 squared? Is this 1 squared? Yep, okay. Now we look at 2 and we loop over the entire array, but we would need to still splice, or we'd need a way to remember how many times, we've already encountered this 4, so we can't also apply this 4 to this. We need to make sure that there's the same frequency of values. Anyway, just to show you how it works, as we go through, why don't I just do a console.log array2 so you can see it shrink as we go. And then here I'll call same on those 2, and let's execute it. And you can see the first time through, it looks like this. And then we're looking for a 1, so we remove 1, and now array2 looks like this. Next time through, we're looking for 2 squared, so we remove 4, and we have this. Next time through, we're looking for 3 squared, which is 9. We remove it, we end up with this. And then next time through, we look for 2 squared, and then we're done. We hit the end of the loop, and we return true. Okay, so that's the naive approach because it is O of n squared. It's quadratic time. This index of is iterating over the entire array, or potentially iterating over the entire array, which is a nested loop. So as n grows, the length of our arrays, this grows, as does this, and it's nested, so that's a quadratic relationship. We always want to try and avoid nested loops whenever possible. So this is where the frequency counter pattern comes in. Instead of looping over the first array and then checking for each value in a sub loop over the second array, we can loop over each array one time individually, which is what I'm doing here. So here's one loop, here's another loop. Remember that 2 loops is vastly better than 2 nested loops. 2 separate loops, this is going to be 2n. If n is 1,000 characters or 1,000 elements, this means 2,000 iterations. But if we have 1,000 on the outer loop and then 1,000 times on the inner loop, we're looking at 1,000 times 1,000, which is 1,000,000 compared to, what did we say, 2,000? Anyway, so I won't make you, study this in the browser here or in the slides. I'll show it to you and show you how it works, but it is O of n, so it's linear time, much better than O of n squared. All right, so here it is. Paste in my same line that already says same, very confusing. And let's step through the basic idea here. So we use an object, and there's actually 2 objects, and each one is going to it's going to count the frequency of individual values in the arrays. So we'll end up with 2 objects at the end. Let me just print them out so you can see. Let's do console.log frequency counter 1. So that applies to our first array, and then console.log frequency counter 2. And I'll just start by running this code so you can see what we end up with. This is so we get true, that's our return value, because these 2 are the same according to what it should return true. That's what we want. But if we look at these objects that were generated, we end up with each object has a value or a key, like 1, and then it tells us the number of times it occurs in that list. Then we look at 2. The number of times 2 is in that list, 2. We look at the number of times 3 is in that list, 1, right? If we look at this, we're compiling an object that just tells us how many times each value is in that array. And then same thing down here, except we're doing it for the second array. So we say there is 1, 9. There are 2 4s. There's 1, 1. Then the magic is, so constructing this only is one iteration over each array to make this. It's not that hard. But then the magic part is that we then just do one more loop. And we loop over either one. You could do it either direction. But we loop over the first object here. And for each thing, we take a look at, one is a simple example. I shouldn't use that one. Let's take a look at 2. We look at 2. And we see that it exists, or it occurs 2 times. So that tells us that we need to have 4 occur 2 times in our other object. Or we look at 3, it occurs 1 time in our main first object, the first array. So that tells us 9 needs to occur 1 time. 3 squared, 3 times 3 is 9 in the second array. So that's what this logic is doing here. So to help me illustrate this, I've updated this. I've added a 5 and an 11. So these are the same length, but they're not the same as far as our criteria, because this 5 does not have a 25 corresponding to it. And we have an 11, we don't have whatever the square root of 11 is in here. Okay, so if I execute this now, I also moved my console.logs up so that we can see them, because I had them down here and we were returning false and we wouldn't see them printed out. Anyway, what's happening now is that we're looping over this first frequency counter object, this thing that we constructed. Constructing it was relatively simple. Hopefully that part makes sense. We start with an empty object, and then we just loop over every value in the array. You could use a for loop. I like using a for of. If you're not familiar with the for of syntax, it's just a nice way of looping over like an array or a string. We just make a placeholder variable like val, and that corresponds to each element in the array. So for each val in array 1, we're going to add 1 to the frequency counter if it's already in there, or we're going to initialize it to 1. So we end up with just this little object that tells us how many times each thing, each element occurs in that list. Then we loop over this first one, and we're going to look at each key. So we're going to look at 1, which 1 is boring, so I'm going to skip it. We're going to look at 2, and we check, is 2 squared? That's what this is. Is that a key in frequency counter 2? So 2 squared is 4. So is there any 4 in our second object? And there is. So this part doesn't return false. Then we check, okay, do the values correspond? If there were 2 2s, there needs to be 2 4s. And if there's not, if there's a mismatch, we return false. So it's not just a matter of checking if there is a 4. We need to make sure there are 2 4s, as we've discussed. Then we keep going, we hit 3, and we check, is 9 in the second object? And it is. And do the values match? 1 matches 1. Then we get to 5. Is there 5 squared, which is 25. Is there a 25? Nope. So we return false. So hopefully you can see why this is better, at least in terms of big O complexity, as we increase the size of these arrays. We're talking about how many loops here? 3 loops over the entire size of the array. Whatever the largest array is, let's just say, they need to be the same size in order for us to even make it to this point. Because if they are mismatched, we quit right here. So our 2 arrays have to be the same size. Let's say 1,000, like we've already talked about, 1,000 elements. We have roughly 3,000 iterations. Here's 1,000, here's 1,000, and here's 1,000 more. And remember that it's very easy. It's quick to access data inside of an object. It doesn't matter how many things are in there. It's just the way that objects work. We actually talk more about this later in the course. So this is 3n, roughly, where n is the length of the arrays, and we simplify that just to O of n, complexity. Compare that to our naive approach, where we have n squared. So if we're talking about, 1,000, a length of 1,000 for each array, that's 1,000,000 iterations if we have a nested loop. Yes, again, we're using index of, but we're talking about a nested loop. That's what index of is doing. It's just a shortcut, so we don't have to type it all out. Inside of a loop, that's roughly 1,000,000 operations, worst case. So this is a lot worse when we put it that way. So the idea behind the frequency counter, usually use an object, and you use that object to construct a profile, sort of a way of breaking down the contents of an array or a string, usually some sort of linear structure like that, an array or a string, and then you're able to quickly compare that breakdown to how another object looks that was constructed from a string or an array. So we had 2 arrays. We break them down into objects that sort of classify what's in those arrays, and then we can compare those objects. And this allows us to improve our code significantly. So I'm going to show you another example coming up that has to do with anagrams. Hopefully it will help cement how this works, and then we'll move on to another pattern.